Okay, number one, we've got 5x minus 1 over x squared minus x minus 2. The first thing you want to do is you want to look at this and look at the highest powered term in the numerator, the highest powered term in the denominator, and you want to ask yourself, is this an improper fraction? If the degree of the highest powered term in the numerator is the same, okay, or higher, then it's an improper fraction and you're going to have to do long division first. And we'll talk about that in example number 5. But for this one, you can see that it's actually the denominator's degree that is higher. So this is not an improper fraction. So the next thing we want to do is we want to factor the denominator as much as you can. So here you can see that this is going to factor to x minus 2 and x plus 1. Okay, so what I'm going to do is I'm just going to kind of draw like a line through that. This is our new denominator. And you can see when you look at these denominators that these are what they call distinct, meaning different, linear factors. Linear meaning like these are to the first degree. So what we're going to do is we're going to break this up into our partial fractions like so. We've got x minus 2, and we also have x plus 1. And what you want is you want the numerator's power to be 1 degree lower than the denominator's highest power. So in this case, this is first degree. We really want this to be a constant. So I'm going to make this the constant a. And here we have x to the first. We're going to want to make this the constant b. Now you want to pick a different variable. So now what we're doing is we're basically breaking this down into partial fractions. These are a little bit simpler to work with when you get to some types of problems like in calculus where you're doing integration. These might be easier to work with individually as opposed to this larger, more complicated fraction. So now what we're going to do is we're going to find out what are our a values and our b values. Well, we're going to treat this like an equation, and what we're going to do is we're going to clear the denominators. Okay, and the best way to do that is to multiply through by the common denominator. Now the common denominator is going to be this x minus 2, x plus 1. This is our least common multiple. So what I'm going to do is I'm just going to write that over here, x minus 2 times x plus 1. And what we're going to do is we're going to think of this as a group, and we're going to distribute it to here, we're going to distribute it to here, we're going to distribute it to here. And the reason it works is because you're multiplying both sides by that same quantity. So we're not changing the equation, we're just changing the way that it looks. So when we distribute this x minus 2 times x plus 1 times this first fraction, you can see that the denominators are going to cancel with these here in the numerator, which is just going to leave us with 5x minus 1. When we distribute this to this fraction, you can see that x minus 2's are going to cancel, see denominator and numerator, and that's just going to leave us with a times x plus 1. And then over here, when we distribute it to this last fraction, you can see the x plus 1's are going to cancel numerator and denominator, and we're just going to have b times x minus 2. So now we've got a little bit simpler equation to work with. What we're going to do in this particular example is I'm going to show you how to pick strategic values of x. Some teachers refer to this as finding the zeros. And what you're doing is you're just setting this group here, or this group, okay, these factors equal to 0. So for example, if I set x plus 1 equal to 0, I get negative 1. So what I'm going to do is I'm just going to say, let's let x equal negative 1. And if I put negative 1 in here, I get negative 5 minus 1 is negative 6. If I put negative 1 in here for x, I get 0 times a, which is just 0. That cancels out. And negative 1 minus 2 is negative 3 times b gives us negative b times 3, okay? Or negative 3b, I should say. So now what we want to do is we want to divide both sides by negative 3, and you can see that b is equal to 2. Okay, now we know what b is. We need to find out what a is. We already let x equal negative 1. Let's set this factor equal to 0. Let's let x equal 2. And again, the reason that we're doing that is because 2 minus 2 is 0. That's going to cancel out this whole term. And so then that'll allow us to solve for a. This doesn't work in every problem, and I'll show you some other examples. But sometimes this is a quicker way to do it. So let's go ahead and do that now. We're going to let x equal 2. Let me just write that down. And if we put 2 in here, you can see we're going to get 2 times 5 is 10, minus 1 is 9. And over here we have 2 plus 1 is 3 times a is 3a. And over here 2 minus 2 is 0 times b is 0. That just cancels out. So you can see here if we divide both sides by 3, a is coming out to 3. Okay, now we know what our a and our b value are. The last step that you're going to want to do is just rewrite this showing your result. So I'm just going to say over here 5x minus 1 all divided by x squared minus x minus 2 is equal to a, which is 3 over x minus 2, plus our b value, which we said was 2 over x plus 1. And this is your partial fraction decomposition. If you want to check your work, Go ahead and combine these two fractions together, getting a common denominator, and you'll see that it equals this one on the left, and you got it. Okay, number 2, we have a little bit more challenging problem now. We've got 2x squared minus 11x plus 17 all over this denominator. The first thing you want to do is you want to ask yourself, is this an improper fraction? And the way you do that is you look at the highest powered term in the numerator, the highest powered term in the denominator, and if this one in the numerator is higher or equal to the highest powered term in the denominator, then you have an improper fraction. You have to do polynomial long division or synthetic division, depending on the problem, to rewrite it. Okay, and then you'll proceed from there to do the partial fraction decomposition. But here you can see that this denominator's power is higher than the numerator. It's not improper. The next thing we want to do is we want to factor that denominator as much as we can. Now, you can see there's 4 terms here. Normally I would try factoring by grouping. Unfortunately, this one doesn't factor by grouping, so what we're going to have to do is use our rational root theorem or rational zero theorem, and you take all the factors of 9 over all the factors of leading coefficient 1, positive or negative, and you test those out using synthetic division. So let me just do that. If you need to review the rational root theorem, you can check that out on my channel, but let me just show you that part really quick, because sometimes your teacher's going to give you ones that are not factored. Sometimes the denominator will already be factored, so it'll be a little bit easier. But let me just do the synthetic division here. We multiply in the diagonal, we add straight down, we multiply in the diagonal, we add straight down, we multiply in the diagonal, and we add straight down. See how we have a 0 remainder? That tells us that 1 is a 0, x minus 1 is a factor, and it brings it down from x cubed to x squared. And we can factor this further. This is going to be x minus 3 times x minus 3 times x minus 1. Now we've got it completely factored, and what you'll notice in this problem is that we have an x minus 3 twice. This is what's called a repeated linear factor, linear meaning first degree. So how do we handle repeated linear factor? Well, what we're going to do is we're going to go over here to our partial fraction decomposition. We've got x minus 1 is one of our denominators, okay? We've got x minus 3 as one of our denominators, and we have x minus 3 squared. Now, if there was 3 x minus 3's, then we would also have an x minus 3 cubed. And what you're doing is you're saying, well, you know, when I combine these together, you know, I have to consider that there could be an x minus 3 and an x minus 3 squared, or there might just be an x minus 3 squared and not this x minus 3. But we won't know yet until we do, you know, all the arithmetic here. So this is our breakdown. And again, we've got A, we've got B, and we've got C. So you just, whatever's in the parentheses here, you just want this numerator to be 1 degree lower. Since that's first degree, that's going to be a constant. Okay, so now we have our basic setup. The rest, we just have to clear the denominators and solve the equation for A, B, and C, and then we've got our partial fraction decomposition. Now this is where students sometimes get stuck in all the arithmetic, so I want to show you the strategy here. We're going to multiply through by the common denominator. And remember, this factored as x minus 1, x minus 3 times x minus 3, or x minus 3 squared. So I'm just going to draw a line through this. This is our new denominator. So if we multiply through each one of these terms, we're multiplying the left side and the right side by x minus 1, x minus 3 squared, what's going to happen is it's going to clear the denominator. So let me just write that over here, x minus 1 and x minus 3 squared. So we're going to distribute to this first fraction, which is just going to give us 2x squared minus 11x plus 17. When we distribute to here, the x minus 1's are going to cancel, so we're going to have a times x minus 3 squared. When we distribute to this fraction, one of the x minus 3's and one of the x minus 3's is going to cancel, leaving us b times x minus 1, x minus 3. And then when we distribute to here, the last term, the x minus 3 squares are going to cancel, so we're just going to have c times x minus 1. Okay, so this is the equation that we're going to be solving. We're going to be picking strategic values of x to eliminate some of these terms, so it allows us to solve for either a, b, or c. Now, a good first step here, excuse me, is let's let x equal 1. So if we let x equals 1, that's going to make this whole group equal to 0. It's going to make this whole group equal to 0, which is going to allow us to solve for a. So if we put 1 in for x, make sure you put it into both sides of the equation, you're going to get 2 minus 11, which is negative 9, plus 17, which is 8. So we have 8 equals 1 minus 3, which is negative 2 squared, which is 4. So we get 4a, and we said that these terms canceled, so you can see that a is equal to 2. Okay, great. So now we want to let x equal 3. Now why 3? Because 3 is going to cancel out this group. 3 is going to cancel out this group, because if this is 0, 0 times anything is 0. And that's going to give us 3 minus 1 is 2c. So we have 2c equals 3 squared is 9 times 2 is 18 plus 17 is 35 minus 33 is 2. So you can see that we have c is equal to 1. Now all we have to do is solve for b. Now you're probably saying at this point, Mario, what are we going to do? We've already used our zeros. We made this equal to 0, 3. We made this equal to 0 by letting x equal 1. Let's just let x equal 0. Okay, so if we let x equal 0, 0 is always easy to work with, because this is going to make this 0, that's 17. And that's going to be, let's see, 0 minus 3 is negative 3 squared, which is 9, times a, which is 2, so that's 18. Over here we have negative 1 times negative 3 is 3b. Whoops. And then this over here is going to be 0 minus negative 1 is negative 1 times c, which is 1, so that gives us negative 1. So now all we have left to solve for is b, and you can see we have 17 and 17. So if we subtract 17 from both sides, we get 3b is equal to 0. Divide both sides by 3, and we get b is equal to 0. And so that's kind of interesting. So in this particular one, this term, is just 0. We didn't actually have that term. Sometimes you will have an x minus 3 and an x minus 3 squared term, so you want to make sure you consider both of those cases. But let's go ahead and write our final result. So our final result of our partial fraction decomposition is, you want to write the original rational expression, the original fraction, which was x cubed minus 7x squared plus 15x minus 9. And the reason you're doing this is because somebody might have made this b and this a, or they might have changed the variables. So your a, b, and c might be different than your neighbor's a, b, and c. So here we've got 2 over x minus 1. b was 0, so I'm not going to write that term. And then c is 1 over x minus 3, the quantity squared. That's your partial fraction decomposition, and you got it. If you want to check your work, get a common denominator, combine these back into one fraction, and you're going to get back the original rational expression. Okay, number 3, we've got 7x squared minus 7x plus 18 all over x cubed plus 8. Well, the first thing you want to do, like normal, is you want to look and see, is this an improper fraction? Well, we can see that the degree in the denominator is higher than the degree in the numerator, so this is not an improper fraction. The next step is to factor the denominator as much as you can. And one thing you'll notice here is that this is a sum of 2 perfect cubes. So you want to review your factoring sum of 2 cubes if you haven't memorized that already. This is going to factor to x plus 2, x squared minus 2x plus 2 squared, which is 4. So I'm just going to cross that out. This is equal to this denominator here. We can't factor this trinomial any further, so that's as far as we can go with this factorization. Now, one thing that you'll notice here is that we have a linear factor. See, this is to the first degree, and we have what's called a quadratic, or a second degree factor. So this is different than the ones we've worked with so far. So the way we're going to do this is we've got x plus 2, okay, as one of our denominators. In our other fraction, we're going to have a denominator of x squared minus 2x plus 4. And again, remember, if you were to combine these together into one fraction, you have to get a common denominator. This would be your common denominator. So all we're doing is breaking this down into partial fractions. Now remember, this is a first degree, like x to the first. We want the numerator to be 1 degree less. So I'm going to make this a constant, and we're just going to call it the a. Over here we have a second degree denominator, so we want this to be 1 degree less. So I'm going to make this linear bx plus c. Now what would happen if this was a cubic, x cubed? Then I would do bx squared plus cx plus d. What would happen if this was x to the fourth? Then I would do bx cubed plus cx squared plus dx plus e. So you understand how that works. So it's always 1 degree less, and you want to go down in descending order to the constant. So now we've got our partial fractions. The only thing we need to do now, the only thing, really this is the main part of the problem, this is the toughest part, is clearing the denominators and solving for our a, b, and c in this case. So we know what our common denominator is. It's this x plus 2, x squared minus 2x plus 4. So what we're going to do is we're going to multiply the left side and the right side of the equation by that common denominator to clear the denominator. So if I distribute this to the first fraction, these are going to cancel, right? So that's going to leave us with 7x squared minus 7x plus 18. If we distribute it to this term here, the x plus 2's are going to cancel, leaving us with a times x squared minus 2x plus 4. If we distribute to here, the x squared minus 2x plus 4s are going to cancel, leaving us with bx plus c times x plus 2. Okay, so you're with me so far? So now what we want to do is we're going to do a little different technique here. We're not going to pick strategic values of x, the zeros. We're going to actually simplify this out a little bit. So I'm going to distribute the a, so I get ax squared minus 2ax plus 4a. I'm just distributing. Here I'm going to FOIL or just do the distributive property twice. So that's bx squared plus 2bx plus cx plus 2c, okay? And now what I'm going to do is I'm going to collect like terms. So what I mean by that is you see how we have ax squared and bx squared? So I'm going to write this as a plus b times x squared, because you can see this will be ax squared plus bx squared, which are these two terms. Let's collect the ones that have an x in them now. So we've got this one, and this one, and this one. So here I'm going to write this as negative 2a plus 2b plus c times x. Okay, and again, you can see I just factored out the x out of all three of these terms. And then now we're just left with the constants, which you can see we've got 4a and 2c. So I'm going to say plus 4a plus 2c is equal to this over here, 7x squared minus 7x plus 18. Okay, so now what we're going to do is we're going to set the x squareds equal to each other. See how this is a plus bx squared and this is 7x squared? So one of our equations is going to be a plus b is equal to 7. We've got over here, see these x's, these x terms we want to set equal to each other. So we have negative 2a plus 2b plus c is equal to a negative 7. And then we want to set our constant terms on the left side and the right side equal to each other. So we have 4a plus 2c is equal to 18. So now all we have to do is solve this system of equations. And there's a lot of different techniques you already know about how to solve systems of equations, like matrices and Cramer's rule and elimination method and etc. But I think what I'm going to do for this one is I'm just going to do the elimination method. And what you'll notice here is that we have, let's see, we've got this first equation just has a and b's in it. Okay. The second and third equations, you've got these ones that have c's. Let's see if we can eliminate the c's by combining the second and third equation. So I'm going to multiply this middle equation by negative 2. That way I'll have 2c and negative 2c. When I add those together, the c's will cancel, leaving us with an equation with just a's and b's, which we then can combine with the first equation. Okay, so if I multiply by negative 2, and so we get 4a, let's see, this is going to give us a negative 4b, we get a negative 2c, and we get positive 14. So in the bottom equation, I'm just going to bring over, we have 4a plus 2c is equal to 18. And now you can see if we add straight down here, we get, let's see, we get 8a, we've got negative 4b, the c's cancel, and we get 32. So notice we have a and b. The first equation also has an a and a b in it, so let me bring that down here. A plus b is equal to 7. And what we want to do now is we want to combine these to eliminate the a's or the b's. So I'm going to multiply the bottom equation by 4. So that's going to give us 4a plus 4b is equal to 28. And so now what we can do is, let me just bring this equation down here. We've got 8a minus 4b is equal to 32. If we combine these together, we get 12a. The b's cancel, and we get 60. Divide by 12, you can see that a is equal to 5. Okay, so now what we have to do is just put the 5 back in. Let's just say we put it in here. So that means that b is equal to 2. Okay, so we know b is equal to 2. And now we know a and b. Let's solve for c. So if a is 5, that's going to make this 20. Okay, and then if we subtract 20 from both sides, we get negative 2. So that means that c is equal to negative 1. So we have our a, b, and c. The last thing we need to do is rewrite our partial fractions. So let me go ahead and do that. I'll put it right here. Okay, so we've got 7x squared minus 7x plus 18, all divided by x cubed plus 8. And that equals a, which was 5, over x plus 2, plus b, which is 2x, c was negative 1, all divided by x squared minus 2x plus 4. If you want to double check your work, you can combine these two fractions together by getting a common denominator, and you'll get back that original rational expression. Okay, number 4, you can see we've got an x to the 4th degree in the numerator. The denominator, luckily this one's already been factored for us, but notice we have x squared, which is x to the 4th, times this x is x to the 5th. Since we have a 5th degree in the denominator, a 4th degree in the numerator, this is not an improper fraction. If the numerator was the same power or higher than the greatest degree in the denominator, then it would be improper. We'd have to do our long division first. So this one's not improper. The next thing we want to do, since it's already factored for us, is we want to just break it up into our partial fractions. Now, what we have here is we have a quadratic. See how it's a 2nd degree? Squared. So this is called a repeated quadratic type of problem. And then we also have a linear factor. So the way we're going to handle our repeated quadratic factor is we've got x squared plus 2. Okay, we also are going to have to consider that it could be, x squared plus 2 squared. See, when you combine these together to get a common, you're going to have x squared plus 2 squared. And then also, we've got the x plus 3. Now, say this was x squared plus 2 cubed, then we'd have to have x squared plus 2 to the 1st, x squared plus 2 to the 2nd, and another x squared plus 2 to the 3rd, right? So you want to consider all 3 of those cases. Notice how this is 2nd degree, so in our numerator, we want this to be 1 degree lower. So that's why I have ax plus b. If this was a cubic, I'd have to do ax squared plus bx plus c. Same thing here. You take what's on the inside, that's a quadratic, so we want this to be linear, so cx plus d. And then over here, this is linear x to the 1st. I just want this to be a constant e. Make sure you don't repeat any of your variables here, okay? And so now what we have to do is just go ahead and clear the denominators by multiplying through by this common denominator, which is the x squared plus 2 squared times x plus 3. So if we distribute this to the first fraction, that's going to clear the denominator, and we're just going to be left with negative x to the 4th plus 3x cubed plus 6x squared plus 11x plus 20. This is probably one of the toughest problems when you have the repeated quadratic, because you can see you've got a lot of variables here. But I'm going to show you how to work with this. So when we distribute it to this next one, see how the x squared plus 2, one of these cancels with this one. So you just are left with ax plus b times x squared plus 2 and x plus 3. When you distribute to this one, the x squared plus 2 squareds cancel, so you just have a cx plus d times an x plus 3. And when you distribute to this one, the x plus 3's cancel, and you just have an e times x squared plus 2 squared. Okay, so now we want to FOIL all this out. And so what we want to do here is, let's start by multiplying these together. We've got x cubed plus 3x squared plus 2x plus 6, all multiplied by the ax plus b. And then over here, if we FOIL this out, we distribute the cx, we get cx squared plus 3cx plus dx plus 3d. And then if we multiply this part out, we have e times x to the 4th plus 4x squared plus 4. Okay, now if we distribute the ax, we get ax to the 4th plus 3ax cubed plus 2ax squared plus 6ax. And if we distribute the b, we get plus bx cubed plus 3bx squared plus 2bx plus 6b. Okay, and so I'm just going to cross this out. So we have all of this plus all of this, and if we distribute the e, we get ex to the 4th plus 4ex squared plus 4e. Just cross that out, that's equal to this. So what we want to do is we want to combine or group like terms. So we've got our x to the 4th, so ax to the 4th and ex to the 4th. So that's going to be a plus e times x to the 4th. Okay, let's group our x cubes now. We've got 3ax cubed, so that's going to be 3a. Let's see, other x cubes, we've got plus bx cubed, and that's it. And then for the x squareds, we've got 2ax squared plus 3bx squared plus cx squared plus 4e x squared. Okay, and then for our x's, we have 6a x plus 2b x plus 3cx plus dx, And then for our constants, we have 6b, and we've got C3d, and we have 4e. Okay, so now what we want to do is we want to set these equal to the left side of the equation. So see how this is negative 1x to the fourth, and this is a plus e x to the fourth? We want to set those coefficients equal, so we have, let's write it over here. We've got a plus e equals negative 1. Okay, now for the x cubes, we have 3a plus 1b is equal to 3x cubed, so I'll just say equals 3. And then for the x squareds, we have 2a plus 3b plus c plus 4e is equal to 11. And then for the x's, we have 6a plus 2b plus 3c plus d is equal to 11. Is equal to, this one was 6, okay, equals 6. That's the x squareds. This is 11. That's for the x's. And then for the constants, equals 20, we have 6b plus 3d plus 4e is equal to 20. So notice what we have here is we have 5 variables, a, b, c, d, and e. We have 5 equations, so we can solve this system for a, b, c, d, and e. Now you can do this a lot of different ways, but what I want to show you is how to use the graphing calculator and use the row-reduced echelon form. So what I'm going to do is I'm going to write this as an augmented matrix. I'm going to take the coefficients. We've got 1a, 0b, 0c, 0d, 1e is equal to negative 1. Okay, and then for this one we've got 3a, 1b, 0c, 0d, 0e equals 3. We've got 2a, 3b, 1c, 0d, 4e equals 6. And then over here we've got 6a, 2b, 3c, 1d, and 0e is equal to 11. And then the last equation we have 0a, we have 6b, and then we've got 0c, 3d, and 4e. So we've got 3d, 4e, and that equals 20. So let's go ahead and put this into our graphing calculator. I'll show you that next. So what you want to do is you want to go over to second, and then matrix, which is on the left-hand side here. And what we're going to do is we're going to arrow to the right where it says edit, and we're going to press enter. And you can see that what we want is a 5 by 6. We want 5 rows and we want 6 columns. And I entered the coefficients in our system on the left-hand side of the matrix. I entered the solutions here on that right column of the augmented matrix. So now what we want to do is we want to press, this is really important, you want to press second quit. That takes you back to the home screen. You want to press then second matrix. And then what you want to do is you want to go to the math, so arrow to the right, and you want to arrow down to where it says row reduced echelon form, RREF. It's letter B here. If we press enter and we go back to the matrix, second matrix, we want to select matrix A. So I'm going to press enter for matrix A, press enter one more time, and then there's our row reduced echelon form. Okay, so you can see we've figured out that our A value is 0, our B was 3, our C is 1, our D is 2, and our E is negative 1. If we put those back in, we've got our partial fraction decomposition. So since A was 0, that means this AX is 0. So we just have B, which is 3 over x squared plus 2. We have our C value, which is 1, so that's 1x plus 2, or you could just say x plus 2 over x squared plus 2 squared. And then our E value was negative 1, so I just wrote this as minus 1 over x plus 3, and you've got your partial fraction decomposition, and you got it. Okay, for number 5, what you'll notice, or what jumps out at you right away, is that you see how this is a 4th degree in the numerator, only a 2nd degree in the denominator. When this numerator's degree is greater than or equal to the highest degree in the denominator, you have an improper fraction on your hands, and what you want to do is you want to do polynomial long division. So I'm going to see how many times does x squared minus 4 go into x to the 4th plus 2x cubed minus 4x squared minus 7x minus 6. So if you need to review polynomial long division, but how many times does x squared go into x to the 4th? It goes in there x squared times. If I distribute the x squared, I get x to the 4th minus 4x squared, and then we subtract, which is like changing the signs to the opposite and adding. So these cancel out, we have 2x cubed minus 7x minus 6. How many times does x squared go into 2x cubed? It goes in 2x times. If we distribute that 2x now, we get 2x cubed minus 8x, and if we subtract, which is like changing the signs and adding, you can see that these cancel, and we get x minus 6. And notice that this is x to the first, this is x squared. Since this is a lower degree, that's our remainder, and we put the remainder over the divisor. And now what we want to do is we want to do our partial fraction decomposition on this right here, okay, this fraction. So let's go ahead and jump down here. We've got x minus 6 over x squared minus 4. But notice that x squared minus 4 is actually a difference of two squares, x plus 2, x minus 2. So I'm just going to cross that out. And when we break this down, you can see these are distinct linear factors. So what we have is we have x plus 2 and x minus 2. And because these are linear, the numerator is going to be 1 degree lower. It's going to be a constant. And all we have to do now is multiply through by the common denominator, which is going to be x plus 2, x minus 2. If we distribute to the first fraction, the x plus 2, x minus 2's cancel, leaving us with x minus 6. And we distribute to here, you can see the x plus 2's cancel. We have a times x minus 2. If we distribute to this fraction here, the x minus 2's cancel, and we have b times x plus 2. Now, by picking strategic values of x, if we let x equal 2, 2 minus 2 is 0. That cancels out this group. 2 plus 2 is 4, so we get 4b equals negative 4. So that means that b is negative 1. And if we let x equal negative 2, that's going to make this group 0. So that's going to be negative 4a is equal to negative 8 divided by negative 4. And you can see that a is equal to positive 2. So that means that this fraction here is actually equal to, let's see, a, which is 2 over x plus 2 plus negative 1 over x minus 2. But remember, this is the part that students sometimes forget, is that we also had this x squared plus 2x. So really, if we take this whole fraction and we break it down, it's going to break down into x squared plus 2x plus this fraction, which we broke it down into this, which remember a was 2 over x plus 2. And then b was negative 1, so I'm just going to write this as a minus 1 over x minus 2. And that's your complete partial fraction decomposition. If you were to get common denominators for all these terms, combine them together into one fraction, you would get the original back. So that's how you do the improper fraction ones.